All right, let's begin chapter 9 on transformations. And the first transformation we're going to look at is translations. The transformation of a geometric figure is the function or mapping that results in the change of position, shape, size, or figure. That's the technical definition. What a transformation is, we're going to look at the main ones are going to be translations. We're going to look at rotations. We're going to look at dilations. We're going to look at the different types when we do multiple transformations. Okay, we'll do reflections. So in a transformation, the original figure is what we call the preimage. It's important to know which one we're talking about, the preimage and the image. Preimage means it come before, so it's always the first one. The image is always our result. A transformation that preserves distance and angle measure is called a rigid motion, which means we haven't changed the size or shape of our figure. It has just been moved into a different position. It may have been rotated around or flipped, but all the angles and side links, everything's been preserved. The only one that would not be a rigid motion would be a dilation, where you're making something larger or smaller. So a translation is the first one we're going to look at today, and the only one we're going to look at is a transformation that maps all points of a figure in the same distance and also in the same direction. This is kind of like what we call a slide. A composition of transformation is a combination of two or more transformations. So we're going to look at those throughout this chapter when you're combining two different or more different transformations. So let's take a look at the different types of translations. We have the domino flips. That's called a reflection. We're going to have the domino slides, as we're going to look at today, which just causes a translation. And then we have the domino turns, which is going to be called a rotation. Notice in all three of these, the domino did not change the shape. It just changed the way it was oriented. So let's take a look at an example here. Identifying something as a rigid motion. So we discussed about what a rigid motion was and the fact that it preserves angle measure and distance. So as we look at this first one, we have to decide, does in A, B, or C, does the preimage, is there anything happen to it? Does it change size? Is it just rotated? Is it flipped? So we have to decide, what is that transformation? So let's look at A. The preimage is a smaller shape. The image is a larger shape. So does this appear to be a rigid motion? The answer to this one is going to be no. This is a dilation. It's gotten larger. The image is now larger than the preimage, so it is larger. So let's look at this one. Preimage and image. Is this an example of rigid motion? This would be yes. It is. The reason why is because the only thing that's happened is our preimage has been flipped or reflected across the line that crosses through the middle here. So it's reflected around this point, and it is a rigid motion. This right here, this is a composition of transformations. The size and shape is not changed, it's just changed the way it shapes. So what the preimage done has been, it's been slid up and it's been flipped over. So even though it's done two different things, it's still an example of rigid motion because it has preserved angle measure and distance, which means the angles are the same and the side links are also the same. All right, so let's keep moving. Now there's a lot in this lesson here. We're going to learn a lot of technical definitions. We're going to learn a lot of function notation, how to write these things. So in a transformation that maps every point of a figure onto its image may be described with the arrow notation. Prime notation, which you'll see by like an apostrophe, and we call it prime, is sometimes used to identify image points. So instead of naming it a new point, we'll use the prime of the point. So in this diagram here, we have triangle J, K, and Q. Now over here, instead of calling it something else, we're just moving the same point here, this vertice, to a new position. So we call that J prime. K moves to become K prime, and Q becomes Q prime. So we say that K prime is the image of K, Q prime is the image of Q, and J prime is the image of J. So triangle JKQ, and this arrow means maps onto triangle J prime, K prime, and Q prime. Notice that you list the corresponding points in the pre-image image in the same order as you do for corresponding points of congruent or similar figures. So as it went here, J, K, Q, we're going to go J prime, K prime, and Q prime. So you want to make sure that they all match up. So let's take a look at example 2, naming an image and corresponding parts. So as we look at this figure, what are the images of F? So angle F would be mapped onto angle F prime. Angle H would map onto angle H prime. So let's list the corresponding sides. So this we can do by doing that EF, the first two here, they're going to correspond to the first two over here, which means it's going to be E prime and F prime. Then we do the next two, F to G. That's going to correspond to F prime and G prime. And then we'll go from G to H. That's going to go to G prime, H prime. And the last one will be the first and last, so EH is going to be mapped onto E prime and H prime. So these are all the corresponding parts that have been matched up, they've been mapped onto one another. All right, so a translation is a transformation that maps all the points of the figure the same distance in the same direction. So this is one thing you want to say, this is a slide, if you want to write that down. These are sliding it to a new position. So if you write a translation that maps triangle ABC onto triangle A prime, B prime, C prime, and we're going to use this by using a capital T, which stands for translation. So the translation of triangle ABC is going to equal the triangle of A prime, B prime, and C prime. The translation is a rigid motion with the following properties. So what this is what we call function notation, where we write it as T parentheses triangle ABC. This is what's the preimage, this is going to be the image. Capital T for translation. So if T of triangle, the translation of triangle ABC is going to be A prime, B prime, C prime, then the distance from A to A prime, so what they're showing you is here from the distance from A to A prime, will be the same as B to B prime, so this dotted line is the same length as this. It means it's moved in the same amount to each position, and C to C prime. It also means that the distance from A to B should be the same as A prime, B prime. B to C will be the same as B prime, C prime, and A to C is going to be the same distance as A prime to C prime. Everything is remain the same. And each angle is measured will also be the same. A is the same as A prime, B is the same as B prime, and C is the same as C prime. So in this diagram here, that kind of shows you what we're going to be looking at. So in this coordinate plane, each point of triangle ABC is translated 4 units to the right and 2 units down. So anything that goes to the right, we're going to consider to be, like the x's going to the right is always positive. So we're going to call that a positive distance. If we say going to the left, we're going to call that a negative distance. 2 units down, anything down will be a negative distance, and everything up will be a positive distance. So we use negative signs and positive signs to relate that direction. So for each xy pair in figure ABCD is mapped onto x plus 4 and y minus 2. So what this means is for every point here, it's going to move 4 to the right, and we're going to move 2 down. So if you look at A, you're going to go 1, 2, 3, 4, 1, 2, down to this position here for A prime. B will go from 1, 2, 3, and 4 down 2 to B prime. C is going to go 1, 2, 3, and 4 down 2 to C prime, and D will do the following 1, 2, 3, and 4 down 2 to D prime. So the way we write this will be, this is a translation, capital T, kind of with a subscript here. Now these are not parentheses, these are kind of arrows that tells us that 4 and negative 2 is our rule that we're applying on to figure ABCD. So we're going to take each point of ABCD and we're going to add 4 to every x, and we're going to subtract 2 from every y. That'll give us our new position of A prime, B prime, C prime, and D prime. So this will describe the translation where 4 represents units of points moved along the x-axis and negative 2 is on the y-axis. So let's practice one of these ourselves. What are the vertices of the translation of -2, -5 of triangle PQR? Graph the image of PQR. So before we're going to graph this, we're going to graph the pre-image. So let's go over here and mark down our pre-image. So we're going to start off with P, which is going to be at a -2, excuse me, the vertices of P here are going to be at a 2, 1. So on this graph over here, since there's not room on that one to graph, we're going to go 2 and up 1 here. This will be our P. Then we'll go up to Q, which is going to be at 3, 3. So we go over to 3 and up 3. That would be our Q mark here. And then our last one here will be at R, which is at -1 and a +3. So this is our R. So let's take and draw our lines here. And there's triangle PQR. So we're going to take each point here and we're going to map it. Where we take our original point, we're going to map it onto our new point. So we're going to start off with the rule here, which is going to be a -2 for our x and a -5 for our y. So we're going to take the vertices here. And first thing I'm going to do is I'm going to write down my new points. So I'm going to write down my original point P. Well, P is located at 2, 1. I'm going to take my Q, which we said was at 3, 3, and our R, which is at -1, +3. And we're going to apply our rule here, which means I'm going to take each x, and each point here, I'm going to take my x and my y. This is a -1, this is a +3. Then my y value is going to be 1, 3, and 3. So I'm going to subtract 2 for each of my x's. And I'm going to subtract 5 for each of my y's. So this result will give me my P prime. This will give me my Q prime. This will give me my R prime. So -2 minus 2 is going to give us 0. 1 minus 5 is a -4. 3 minus 2 is 1. 3 minus 5 is a -2. -2 minus 1 is a -3. And 3 minus 5 is a -2. So these are my new points. So we'll go mark these here in blue. We'll go to the first one is at 0, -4. So 0 on the x and -4 on the y. This is my point P. Point P prime. So now the other one's going to be at +1, -2. That becomes my Q prime. And then the last one's going to be at -3 and a -2. That would be my R prime. So what we've done is we've shifted each one of these to the left 2, and we've shifted it down 5. So as I draw this one here, you can see a little bit better the image here. One thing you can do is count. You can take each point and go, you could go -2 and then down 1, 2, 3, 4, and 5. 1, 2, 1, 2, 3, 4, and 5. And 1, 2, 1, 2, 3, 4, and 5. So this becomes our new result. All right, so now let's take a look at this, and now let's go back to our original function, and let's move it -2, -3. So we're going to go back to our original function. So I want you to you can do this on the same graph, and I want you to take that new position, and I want you to apply the rule of -2, 3. Okay, so we're going to and when we do this again, we're going to call this our answer is double prime. So that since that tells us we made 2 translations. So pause the video, graph it, and see how you did. Okay, let's see how you did. So we took our prime points, 0, -4, 1, -2, and -3, 2. We applied the rule of -2 and +3 to each of our -2 to our x and 3 to our y. So 0 minus 2 is going to give us -2. and a negative 4 plus 3 is a negative 1. For Q, we're going to get 1, negative 2, and 2 plus 3. And that gives us a negative 1 and a positive 1. And the last one we have negative 3, negative 2, which is going to be a negative 5, and a negative 2 and a positive 3 is a positive 1. So we graph our 3 new points of P double prime, which is at negative 2, negative 1. Q is at negative 1, positive 1. And R double prime is going to be at negative 5 and positive 1. So this is a transformation. This is actually a composition of transformations because we've done 2 different transformations. We've slid it down to this position, then we've slid it to this one. All right, so let's take a look at the next part, writing a rule. So we've graphed it. Now let's take a look at writing a graph based on a picture here. So we want to say, how do we get from this point here in our pre-image to our image point here? And the best way to do this is to always to work backwards. So pick a point and figure out, how did I get from that point to its original position? So let's take a look at P prime. How did I go from here to right here? So what we want to do is we want to do opposite. So we're going to count backwards. 1, 2, 3, 4, 5, 6, 7, and 8. And then we're going to go up 2. Okay, so if we went 7 to the left, that is like a negative 7. But when we're going from here to here, it becomes a positive. So you can start from the negative or positive here. So if we do this, we're going to go over 8 and down to P prime. We'll go over 7 down to P prime. Let's see, did I count that right? 1, 2, 3, 4, 5, 6, 7, 8. So 8. Go over 8 to the right, and then we're going to go down 2. So if they didn't give you a picture, what you're going to do is you're going to pick 2 points. So we picked P and P prime. And what you always want to do is you want to start with the prime one on top. So P prime is equal to, it's located at 5 and 2. And then we take P, which is now located at a negative 3 and a positive 4. So what you want to do is you want to subtract these points here. So you do 5 minus negative 3, which becomes a positive 8. Negative minus a negative and a negative gives us a positive. And 2 minus 4, which is going to be negative 2. So what we're doing is we're basically subtracting these 2 points. So this is your rule. So the rule is going to become, and if we're going to write this in function notation, we're going to say the rule of positive 8, negative 2, so the translation rule of figure P, Q, R, S, which maps onto P prime, Q prime, R prime, and S prime. All right, so now we have this picture here. They say, what is the translation that takes triangle LMN onto triangle L prime, M prime, and N prime? When L prime is at negative 1, negative 2, M is at 3, negative 4, and N prime is at 6, negative 2. So this is our result, and the picture right here that they've given us is the pre-image. These numbers here are the image. This is the pre-image. So what is the rule that describes the translation? So pause your video, come back and check your answer when you're done. All right, so let's take a look here. What you need to do is pick any of the 3 points, L, M, or N. I chose L. You could have chosen M or N and still got the right answer. So I chose L, so I marked the coordinates of that, which is a negative 6, negative 1. And I wrote down the coordinates of L prime, which is 1, negative 2. Then I take the prime position and I subtract the original position. So I take the image minus the pre-image. And the reason why we do this is just to help avoid having to change the signs. So when you subtract here, this becomes 1 minus a negative 6, which becomes positive 6, and so we get 1 plus 6 is 7. 2 minus a negative 1 becomes plus 1, and negative 2 and a positive 1 is a negative 1. So our result here for our rule is going to be 7 plus 7 on the x and a negative 1 on the y. So that means we're going to move 7 to the right, and we're going to move down 1. All right, so let's take a look at composition of transformations on more depth. Okay, so we've done a couple things here. We've looked at how we get how they map on one to another. So now let's take a look at when we combine some things, two or more steps. So the transformation, or excuse me, a composition of transformations is the combination of two or more transformations. In a composition, you perform each transformation on the image of the preceding transformation. So we've kind of been doing that already. So the diagram at the right shows two moves of the black bishop in a chess game. Where is the bishop in relation to its original position? So what I would write here is, to make sure that you understand, I would always in a problem like this, is always let your original position be the coordinates of the origin. So original position. So we're going to say let original position be the origin. So what we're going to do is we're going to start here. We're going to do a transformation that takes, here's our original position right here. And we're going to end up in this position right here. So using our coordinates, we're going to start at our point. So it's going to be our original point here. So the rule here, we're going to say, how do we get over from here to here? So we're going to go over 1, 2, 3, 4 to the right, and then we're going to go 1, 2, 3, 4 down. So we're going to do a translation with a rule of a positive 4 and a negative 4, and we're going to apply it to the origin 0, 0. And that result is going to give us 0 plus 4 and 0 minus 4. And so that becomes our new position. Our position 1 is going to be at a 4, negative 4. So this is our original position. So now let's see where he goes from this one to the second position. So we're going to go back and do a translation. And our new rule is going to be up 2 and over 2. So we're going to go up 2 and over 2. Now this time, instead of using 0, 0, we're going to pick up where we left off, which was at 4, negative 4. And we're going to figure out where is he located now. So we're going to take the 4 and we're going to add 2. We're going to take the negative 4, and I didn't mean to put a parenthesis here. I'm not done with it yet, so we'll put a comma here. And we're going to take the negative 4 and we're going to add 2 to it. And so our result is that then becomes 4 plus 2, which is 6, and negative 4 plus 2, which is negative 2. So this leaves us with our ending position, and so it says, how far does it relate to the original position? Well, it is 6 units to the right, and it is 2 units down. So 6 units to the right and 2 units down. So when you notice, we had a negative here. So what I do is I let my negative be by my word down. This describes it, because where distance is always positive. So we're saying we went 6 units to the right, 6 positive units. If we'd gone to the left, it was a negative 6. We'd say 6 units to the left and 2 units down. If we went up 2 units, we'd say 2 units up. That would describe the position to its original position. So let's take a look at the last one. The bishop moves 3 squares left and 3 squares down. Where's the bishop in relation to its original position? So once again, the original position is where we started at. So if we pick up where we left off and apply the translation rule, then we will discover also where it's located from its original position. So go back and use the position of 6, negative 2 to find out where our new position is located. So pause your video and come back and check your answer when you're done. All right, so let's say he's right here, and he's going to move 3 squares to the left. So we go 1, 2, and 3, 1, 2, and 3. So he's going to end up right here. And so where is that related to his original position? Well, it should be 1, 2, 3 units to the right, and 1, 2, 3, 4, and 5 units down. So if we apply this rule to our position here at 6, negative 2, we do 6 minus 3 to and we do -2 minus 3. That gives us a +3 for our x and a -5 for our y. So this tells us our point is located at 3 units to the right and 5 units down from its original position right here. So anytime you have a problem like this where it describes it, and you'll see maybe in a city block problem, walking so many blocks to the east or the west. East, remember, is going to be your positive, west would be your negative x's, north would be positive y's, south would be your negative y's. And so just make sure you everything start at the origin, and the problem becomes much easier. All right, so that concludes our first lesson in Chapter 9 on translations. If you missed anything, go back and review it by rewatching the video again.